Bismillahirrahmanirrahim. Assalamualaikum students. Welcome to Pakistan School Muscati Learning, and we are learning from our book Amazing Science Grade 4, and I'm your teacher, Ms. Adartiza. Welcome to the science class, students. This is a continuation of unit number 7, Magnets and Magnetisms. Today we will review unit number 7, book pages 61, 62, and 63. We'll do some general discussion related to the magnets and do question number 6, book page number 66. So let's get started, students. Now, who will tell me what is a magnet? Yes, a magnet is an object that can attract metals like iron, steel. That is called magnet. Magnet has two poles. Ends of the magnet has strongest magnetic force. And on the center line, you can see that there is no force or maybe less force of magnet. Like poles repel each other and unlike poles attract each other. Now, students, we already learned about about two kinds of magnets: artificial magnets, which is man-made magnets, and natural magnets, which is called magnetite or lodestone. This is a dark colored rock, dark black color. Okay. So now here comes to the electromagnet, students. An electromagnet is a type of a magnet in which the magnetic field is produced by an electric current. Two forces join together to make electromagnet. As you can see that you can make your own electromagnet. Now comes to the today's work, which is very interesting activity related to book page number 64. What you have to do for this activity, students? You have to make a floating compass. And I've shared the video with you. Before I am sharing, need to explain you that you have to see that how that a magnetized sewing needle float on water to show you the direction of north and south, in which you required strong magnet, needle, which is made up of iron or steel, bowl of water, paper, cardboard that can float on water, scissor to cut it in a circular. Now we will stroking the needle in one direction with one pole of a magnet. At least 20 or 30 times we need to stroke in one direction. As you can see, now the needle magnetized. As I showed you in previous video as well, when it is magnetized, it can behave like a magnet. I will cut the cardboard in a circular, because compass we see that it is a circular. So we are cutting the cardboard in shape of circle. We just try to little bit fold also. Okay, now just pointing the direction and make a little bit fold to it, that we just put our needle over it. Okay, folding from north to south side. Last videos I told you that why it is north and south, because it is always aligned with the direction of Earth's north and south. Just putting on the water. Now we are just comparing with our compass as well. Can you see the needle movement? Now it is aligned. Can you see? North aligned with the north side and south aligned with the south side. Isn't it interesting, students? You can use plastic bottle cap as well to put in your needle. Make a floating compass. You can see the movement as it is already magnetized. So you can see the direction start changing. Again, it will stop in the same aligned direction with north to north and south to south. when it comes to the rest, you can see that isn't it aligned with north and south with south. You can use leaf as well to make your floating compass. Again, it will align with the same direction with our compass, or the compass we will made with needle after being magnetized. So I hope that you enjoy today's activity, students. Now comes to the question answer. Before that, we'll review the force of magnet, in which we learn about the attractive force between two different poles, unlike poles, and repulsive force, two same poles having a repulsion force. Now comes to the today's word, question number 6. It is on your book, page number 66. A part, you can see two magnets and then near with north side to north side. So what happens when they comes near to us? It is having attractive force or repulsive force? Yes, repel each other. They move away from each other. Like poles, repel each other. Now for part B, you see that south going near to south pole of the another magnet. Yes, repel. Same pole, repel each other, moving away from each other. Now for part C. Yes, it is having attractive force. North going towards south. Unlike poles, attract each other. D. Same situation. Unlike poles, attract each other. So students, now it's a trivia time. So, what is a keeper used for? Right, it stops the magnet for losing its magnetism, power of magnet or force of a magnet. Now, how to demagnetize a magnetized needle? Magnetized means you are just stroking it one direction, so the needle behave like a magnet. If we want to demagnetize, means removing the power of magnet, removing the force of the magnet, removing the magnetic power of the needle. So what we will do, we just heat a magnetized needle until it becomes red hot, then cool it. So the magnet becomes demagnetized. Now, I hope that you enjoy learning, students. It's a homework time. And homework is very interesting, especially for those who loves drawing. So what you have to do, you have to draw and label different shapes of magnets, and you have to draw one keeper as well. So I draw bar magnet, horseshoe magnet, ring magnet, and U-shaped magnet. You can make any other magnet which is in your book, page number 61. So the shape of bar magnet, horseshoe. I make a keeper with the horseshoe. Mostly it is used for the U-shaped and horseshoe magnet. So I just make for the horseshoe magnet, it's a keeper. And you already read about the keeper, that what is a keeper? A flat piece of iron. Okay, this is a flat piece of iron placed across the poles of a horseshoe or U-shaped magnet. Okay, it will be placed here or either here. So what is keeper used for? Keepers stop the magnet from losing its magnetism. Okay, don't forget it. So students, now it's time to say Allah Hafiz to everyone. Have a very nice and blessed day. Don't forget to wash your hands after using the gadgets. Allah Hafiz to everyone.